Alright students, before we get started today, you're going to want a few supplies for this set of notes. First of all, you're going to need some colors. I have chosen about 6 different colors. I have a pencil, I have 2 colored pencils, so I've got some colored pens, a normal pencil, 2 colored pencils. I also have a pair of scissors and a glue stick. You can use tape if you don't have a glue stick at home. You also want to make sure that all of your pages printed out. There should be 1, 2, 3, 4, 5, and 6. So there should be 6 pages. This is the one that you're going to be cutting out. Before you start cutting, I suggest that you color in your shapes and then cut them out. So this is a good place to pause and do that now. Okay, our learning objective today is the mid-segment theorem and coordinate proofs. We're going to start with the definition, and it says that a segment that connects the midpoints of 2 sides of a triangle, that is a mid-segment. Every triangle has 3 mid-segments. So you're going to take that triangle that you colored and you cut from the back page, and I have mine here, and we're going to fold each side in half to find the midpoint. So I'm going to take this longest side here first, and I'm going to take this vertex and fold it over here to this vertex. When I match them up, I'm just going to put a little crease right here. And that shows me that this right here is the midpoint of this side. Then I'm going to do that for all 3 sides. So I'm going to fold it again here and put a little crease there. There's my midpoint of this side. And then the short side. Fold it, crease it, and then right there in the crease, that's my midpoint. Okay, so there's my midpoint, all 3 midpoints, a midpoint for each side. Then what you need to do is take your straight edge and you want to connect the dots. So here, taking my straight edge, I'm going to connect the midpoints. Okay, there's 1. 2, and there's my 3rd mid-segment. Okay. Then you're going to want to take your glue stick and just paste it right here. And then label the points. I'm going to call this the big triangle, so I'm going to label this one B, this one up here I, and this one G. That's for the big triangle. And then I'm going to call this one, it's littler, so I'm going to call this one the ant. A-N-T. And what I know here, because of the definition, is that for this triangle, the big triangle, I know that segment AN, segment NT, and segment TA, or AT, doesn't matter, are mid-segments. of the big triangle. Alright, next we have a mid-segment theorem. And my mid-segment theorem says that the segment connecting the midpoints of two sides of a triangle is, you look at this mid-segment, it is blank to the blank blank. Okay, so look at the relationship. And look at the relationship between NT and BG. Those are parallel. Okay, so it's parallel to this third side. And the distance. So if you have some leftover paper from your triangle that you cut, you can use it as a measuring device. So here, I'm going to use this piece of paper and just put a little mark here and here, because that's telling me that NT is that long. Then I go over here and I measure. That's the same as BA, which is the same as AG. Okay, so that means that this NT is going to be half as long as that third side. Okay, so let's write down everything that we know about this triangle now using this theorem. I know that NT happens to be parallel to BG. I also know that NT, without segment notation, because now we're talking about a number, is equal to half of BG. I know that AN, segment AN, is parallel to segment IG. I know that AN is equal to half of IG. And then finally, AT or TA is parallel to BI, and that TA is equal to half of BI. Alright, now for page 2. On page 2, we're going to use some color, and I'm going to choose my pink pen first. And it says, from the theorem, I know that this right here, this mid-segment here, because it tells me right here that this is a mid-segment, this mid-segment here is going to be parallel to this side, and it's also going to be congruent to this segment here and this segment here. And remember that we show that segments are congruent by putting a little hash mark. So I'm going to put a single hash mark here, here, and here. Now I'm going to mark my other sides. So here, this one in green is going to be congruent to this one and this one. I'm going to put 2 hash marks here. Then I'm going to pick a different color. This one here is going to be congruent to this segment and this segment. So I'm going to put 3. 1, 2, 3, 1, 2, 3, and 1, 2, 3. Okay, now that I have my diagram marked, it is going to help me fill in this information here. First of all, JL. JL, that's the one in pink. So JL, what is it congruent to? Well, it's congruent to XK, and it's congruent to KZ. YL, which is in purple, YL is congruent to LZ, and it is also congruent to JK. And the last one, KL, here, is going to be congruent to XJ and JY. Alright, now let's talk about parallel, because that's the other part of the theorem. JK, which is in green, JK oops, sorry, JK in purple, sorry. JK is going to be parallel to this side over here, YZ. JL in pink, is going to be parallel to this side over here, XZ. And then YZ, I'm sorry, XY in green is going to be parallel to KL. Alright, and that's how you do those problems. Next, we have DE is a mid-segment of this triangle ABC, and we are asked to find the value of X. Well, first of all, write down what you know. Since DE is a mid-segment, DE, we know is going to be half of BC. Then, plug in any information that you can figure out from the diagram. In the diagram, we know that DE, X is equal to DE, so I'm going to substitute in the value of X here, equals 1/2 of, and then here we're told that BC is equal to 26, so I'm going to substitute in 26 here. Solving half of 26, I know that X is equal to 13, and there aren't any units displayed, so you just put the word units. Whenever you're asked about length, find the length of something, you want to make sure that you put units. Okay, so that is my answer for this one. This one says DE is a midsegment of triangle ABC, same thing. Find the value of X, but this time X is at a different place. Well, because DE is a midsegment, we need to use the definition of midsegment, which means that it's a segment that connects the midpoint of two sides of a triangle. So that means we know that point E is a midpoint. And it is the midpoint of AC. Okay, well, the definition of midpoint tells us that if that's a midpoint, then this segment here and this segment here are congruent. So we say AE is congruent to EC. And then definition of congruent segment tells us that that just means that they're equal. Okay, so plug in what I know. AE, they say is 6, so that's going to be 6. EC is X, so that's going to be X. So what we found was that X is equal to 6 units. Alright, next page. Alright, here's some more examples. And I'm going to use color again. But before I do that, I'm going to write down everything I know about this diagram here. I am told that DE is a midsegment of this triangle. Okay, since it was on a different page, I'm going to write it down again. Because DE is a midsegment, we know that E is a midpoint. Okay, and then that tells us that AE, since E is a midpoint, we know that AE is congruent to EC. We also know D is a midpoint. So we know that E, we should also put and D are midpoints. Okay, so that means that AE is congruent to EC, and we know that AD is congruent to DB. Okay, and this right here is because of the definition of midpoints. Well, the definition of midpoint, or definition of congruent segment, tells us that that just means that they're equal. So AE equals EC, and AD equals DB. And that's because of definition of congruent segments. Okay, I think we have enough to get started, so let's go ahead and take a look at this first one here. Alright, it says that if AC is 39, then AE equals blank. Okay, so AC happens to be this whole side right here. And I know from up here that I don't have anything that talks about AC. So what I need to start with is, well, what I know. First of all, I know that AE is equal to EC. I do know that, and that's stated above. Okay, stated up there. And then I also know something about these two. I know that AE plus EC is equal to AC. And we haven't seen this one in a while. This one is called the segment addition postulate. Okay, now keep working with what you know. Since I know that these two are equal, I can substitute in. So I know that AE plus AE is equal to AC. What I did was I took out the EC and replaced it with the AE. And that was because of substitution. And then I've got two things that are alike, so I can combine them together. I can write that as 2AE equal to AC. And that is combining like terms. Alright, so now we're at a point where we have to substitute in what we know. We are told that AC is 39, so I'm going to write down 2AE equals 39. Okay, now from algebra, I know that I can divide both sides by 2, so that means that AE is going to equal, and in my calculator, I would plug it in and find that that's 19.5. So AE is 19.5 units. Okay, so remember that this side, that segment is congruent to this segment, and that the whole side added up to be 39 units. Okay. The next one. On this next one, we're talking about AD. So we're talking about this side over here. So we're going to be using that D as the midpoint. So from above, we know that D is a midpoint. We also know that these two segments are congruent, and we know that they are, the distance between those 2 points are equal. So here we know that AD equals DB as stated above. Okay, stated above there. Alright, well, the other thing that we know something about these two, but we want to know about the entire segment. But we don't have anything showing the entire segment. So, again, just like we did above, we're going to have to use the segment addition postulate. So I know that AB is equal to AD plus DB. And again, that's the segment addition postulate. Okay, now substitute in what you know, just like you did above. So AB is equal to AD plus AD, or that's going to be AB is equal to 2AD. This one was substitution. This one was combining like terms. And now we're at a point where we can plug in information. Here, I'm told that AD is 22, so AB is equal to 2 times 22. Well, 2 times 22 is 44. So we know that AB is 44 units. So let's go ahead and mark that on our diagram. I know that this segment is congruent to this segment, and now I know that the whole thing is going to be 44 units, because each piece was 22. Okay, the last one says find the perimeter of ABC. Okay, well, to find the perimeter of ABC, perimeter, capital P, of triangle ABC is equal to AB plus BC plus AC. Okay, well, AB, that was 44 units. I'm going to write it in green because that's the color I used up here. So that was 44 plus BC, which is this side over here, BC in purple, that is 26 according to my diagram. And then AC, which is this side here, was 39 units. And when you add all three numbers up, you should get 109. So this is 109 units. Okay. Next, number 12. On number 12, I am told that I'm given a triangle GHJ, and I am told that A, B, and C are the midpoints. I'm also given a little bit more information. I am told that AC is equal to this algebraic expression, 3y minus 5. So I'm going to take a color and I'll mark AC in purple, and I'm going to label it 3y minus 5. Well, from knowing about midsegments now and about using the midsegment theorem, I know that each one of these is congruent. So I'm going to color those in purple as well. This one and this one. And they're all the same. So I know that this one right here is 3y minus 5, and this one is 3y minus 5. Okay, so I've run out of things to do, so now I move on. So the next piece of information says, and HJ is 4y plus 2. HJ is the whole side. So this whole side over here is equal to 4y plus 2. So now you should be able to see clearly that this plus this is going to equal the whole thing. So that's going to be 3y minus 5 plus 3y minus 5 equals 4y plus 2. That is all the geometry that's involved in this. Now what you have to do is just use your algebra skills. So using my algebra skills, I know that I'm going to clean up this left-hand side. That's going to be 6y minus 10 equals 4y plus 2. Now, I'm going to subtract 4y from both sides, and I'm going to get 2y minus 10 on the left equaling 2 on the right. I'm going to add 10 to both sides, so that means that I get 2y equaling 12, and then dividing by 2, I get y equals 6. But I'm not done, because they didn't want y. They wanted to know what HB was equal to. HB happens to be, I'm going to color it in yellow, highlight it, HB happens to be this piece right here. So what I do is I say HB, which is equal to 3y minus 5, I have to substitute in the 6. So that's going to be 3 times 6 minus 5. 3 times 6 is 18 minus 5. So I know that HB is equal to 13 units. Okay, almost done. Now we're going to our next learning objective, which is coordinate proof. Now on the coordinate proofs, you are supposed to cut out that little square in the back and make sure you color it. Okay, here's mine, and there's the square. That's what we're going to be using in a minute. Okay, so coordinate proofs oh, wait a minute, there was another page before that said more examples. Okay, so we did the more examples, and so now we are ready to move on to coordinate proofs. Okay, so coordinate proofs says placing a geometric figure on a coordinate plane. It involves in assigning coordinates to each vertex and solving a problem using this information. Okay, so here's an example of what this is talking about. Place a square in a coordinate plane in a way that is convenient for finding the length of each side. So this is my coordinate plane. You don't recognize it because I didn't want to draw all 4 quadrants. Here's the first quadrant, this one is the second, this one down here is the third quadrant, and this is the fourth quadrant. Okay, if I want to place this in my first quadrant in a way that's convenient for finding the length, I have to find the distance between all of these points. Remember that it's easier to find distance when I line it up like this. And if I ever have to use the distance formula, it's better if I put it in the corner down here like this. Okay, so here I'm going to label each one of these as, this one right here is going to be C, this one up here is going to be P, this one's going to be H, and this is going to be S. So C, P, H, S. So it says that assigning coordinates to each vertex. So right now we've assigned a name to each vertex. We have C, P, H, and S. And so now what we have to do is assign coordinates. But we don't really know very much about this. Here, I can tell you what C is. C is at point 0, 0. That one's easy. But I don't know the distance between here because there aren't any hash marks to count. All I know is that this right here, the length of X, is equal to D. So from here to here, it's D units long. And then since this is a square, I know that this length here, length Y, that's also going to be D. So P, if I'm looking at point P up here, I do not move right or left, so that's going to be 0, but I'm going to go up D units. So that should be comma D. Alright? And let's do S next. I do move to the right, and I go D units over, but I don't move up or down. So that's going to be D units to the right, 0 for the Y coordinate. Alright, this one up here, to get to H, I have to go D units to the right and D units up. So that's going to be D, comma, D. Alright, so there I have assigned coordinates to each vertex. They're variables, but they are coordinates. Okay, so now it says assigning coordinates to each vertex, and solving a problem using the information. So the next one says find the length of the diagonal of a square. Okay, there are two diagonals. There's PS and there is CH. Put a special note over here because you want to make sure that you always choose the diagonal with one of its endpoint at the origin, because that makes that 0, 0, and that makes it numbers easier to deal with. Okay, so if I want to find the length of CH, I am talking about this diagonal here, and I'm looking for the length. Length means I need to use the distance formula, so I'm going to write that over here. Distance formula. Just to remind myself what that was. Distance formula, which I can find on my formula chart, is equal to x2 minus x1 squared plus y2 minus y1 squared. So that means I'm going to need to use some points. So what I'm really looking for is the distance between CH. C, remember from up here, is at 0, 0, and H is at DD. Okay, so here, that's going to be D minus 0 squared plus D minus 0 squared. That means that D minus 0, that's easy, that's why I wanted you to pick it. D minus 0 is just, that's going to be D squared plus D squared. Or, that's the same thing as two of them, 2D squared. Now remember, we can't leave it that way. We have to simplify it. So remember that you can separate this as square root of 2 times the square root of D squared. And that's just going to be the square root of 2 times D. And that is the length of CH. Okay, so another type of problem that you might have is find the midpoint. So let's remember the midpoint formula. Midpoint formula. The midpoint formula is where you have m is equal to, you add the x's together, x1 plus x2 divided by 2, oops, sorry, comma, and y1 plus y2 divided by 2. It's the average of the x's and the average of the y's. Okay, so since we're going to label this m is the midpoint of CH, so here m is going to equal 0 plus d divided by 2, comma, 0 plus d divided by 2, using those same points. So that means that the m is at d over 2, comma, d over 2. And we are done. The last page is your check for understanding page, and I'm expecting you to have that done when you come to class. There are 6 problems that you're expected to do, so make sure that you have all 6 of these problems completed when you come into class, and this is part of your notes grade. All right, folks, that's it for Notes 5.1.